All right, we're going to look at problem number 16. And this asks us to find a Taylor series for f of x equals 1 over square root of x, centered at x equals 4. The problem with this one is we don't really know anything about 1 over root x. And so we have to build this as a polynomial and hope that we can find a pattern. And so we will start with the function and we will evaluate that at the center, which is 4. So we get 1/2. And then I'm going to take the derivative, which this will be negative 1/2 x to the negative 3/2, which if I take and evaluate this at 4, I get negative 1/2 times 1/8, or negative 1/16. And you can check the math on that, check the math on the derivative. So I'm going to keep going. So I'm going to take the second derivative, which gives me positive 3/4 x to the negative 5/2, and evaluating that at 4, I would get, let's see, 3/4, and then I would get the square root of 4, which is 2, and 2 to the 5th, or to the negative 5th, is 1/32. Multiplying that, we get 3 over 128. F triple prime, and you may wonder how far you really need to go with this. And my suggestion would be this. I tend to go till I get to a third degree polynomial or 4 terms, whichever comes first. Sometimes our third degree polynomial, we don't need to go that far. Typically by then you can see a pattern. We need at least 4 terms though, because if it's going to be alternating, it may start positive, then go negative and turn positive again, but not actually be alternating. Like the next term may be positive, and we would want to check that. So I typically go to the third degree. And we're going to evaluate this at 4 to get negative 15 over 8. And 2 to the 7th is 128. And so multiplying those, we would get negative 15 over 1024. Okay, so now what I'm going to do is I'm going to build this polynomial. So I can say that my function is approximately equal to the Taylor polynomial. Let's say, for example, we do a third degree Taylor polynomial, and it's centered at 4. So I would do my first term. Remember, this will be f of 4 plus f prime of 4 times x minus 4 over 1 factorial plus f double prime of 4 times x minus 4 squared over 2 factorial plus f triple prime of 4 times x minus 4 to the third over 3 factorial. So let's just fill in that information. So our function is approximately equal to this third degree Taylor polynomial, which would be 1/2 minus 1/16 x, oh goodness gracious, x minus 4 plus, and then we'd have 3 1/28 over 2 factorial. So that would give us 3 over 256 times x minus 4 squared plus, oh heavens, I don't know what this will be, negative 15 over 6. So we'd get negative 15 over 6 times 1024. So 6,100, 6 times 4 is 24, 144. Someone should check me on that. I'm going to check myself and I'll correct it if it's wrong. Thankfully that was correct. And so this would be my polynomial, a third degree polynomial. Now if I'm trying to write a true Taylor series, my goal would be to get it in sigma notation. But let's just look at that for a second. Other than knowing it's alternating and knowing we have some x minus 4 to the n power because we're dealing with it being centered at 4, I don't really know. I've got a big gray area because I don't know what this expression is. I don't know how to turn that coefficient that we see there into an expression using n. Probably it has a power of 2 in there because all of those do, but I don't see what this would be. And so it is okay that we happen to have a Taylor series, which is not really in series notation. On an AP exam, you would see it, and maybe they would even clue you in as to what it would look like. But really what I would do just to indicate that I am using a series but don't really know what's happening is I would use those ellipses, that 3 dots, to say, I know this keeps going. It follows the pattern I've already done. As to what that pattern is, I don't really know. In that case, you wouldn't see this third degree information there. But anyway, hopefully that helps for number 16.